Welcome to the Health Deli, your local stop for a fresh take on community health topics. Come on in, grab a number, and let the guys behind the counter, Mark, Ben, and Mike, tell you about today's specials.
Hello, everybody. Welcome back to the Health Deli. It is now officially the Health Deli again, not the Swole Deli. We got a DMCA. It was really bad news, but we're back.
What the hell is a DMCA? Whoops, I just swore. So that means we get an adult rating on this episode. What is a DMCA?
So today we're talking about air pollution, everybody. So I am joined, as you can already tell, by the fantastic Mike Klepser.
Hello, everybody.
Hello. And we have a very special guest on the pod today, Dr. Dylan Brewer. Hello, Dylan. How you doing?
Hello. It's great to be on the deli.
Yeah, just wait. That'll change.
Hopefully not. So as I mentioned, today we're going to be talking all about air pollution. What is it? What are kind of the negative impacts on your health? And then also, how do you actually study something like this? So we're going to kind of get a little bit into some nitty gritties of like study design and these kind of more naturalistic kind of phenomena. But before we jump into that, we'll do a little bit of free samples. Mike, are you working on any episodes you want to tell the people about?
Yeah. So I've had a number of things I've been looking at. One, I want to do an episode on vertigo. Since that's going to be the Mike Health topic of the season, I think.
Okay, so kind of like dizziness and that kind of stuff?
Yeah. Also want to look at maybe doing some impact of good health on outpatient antibiotic use, maybe some spongiform encephalopathies and stuff like that. You know, like mad cow disease and whatnot. So
yeah, I actually did look into mad cow disease too, and I wanted to do an episode on that. So maybe we can collab on that. Very interesting topic. I'm actually working on an episode that's all about, so there's this new weight loss drug that I'm sure both of you have probably heard of, like the Wegovy, those kinds of things that are kind of coming out. And so I'm doing an episode about, are those things actually effective at causing people to lose weight? Because they've been all over the news.
Oh yeah, that'd be a good one.
Yeah, for sure.
Hey, you want to say hi to our guy over there?
Hello.
That's Andrew. He's stacking the bottles back there in the beverage section. We just got a new shipment of custom kind of
some like sodas,
seltzer waters, back there, and hope he doesn't drop them on himself. So yeah, it's all good.
Artisanal hard seltzers are actually fantastic. If you haven't had any of those.
No.
I thought the deli was kind of an allegory, so I'm a little surprised, but it's very interesting.
Well, we record where we can.
Yeah, and we're here in the glorious Health Deli Studios at Fair State University Television and Digital Media Production group. So, again, we're so excited to be here.
Yeah, for sure. Thank you to them for housing us as always, because I know we are quite a handful.
And they need to sterilize the place once we leave. At least Mark's not here, so they don't have to fumigate it this time.
Yes, I'm sure they'll appreciate that. Cool. All right. Well, before we jump into the topic proper, Dylan or Dr. Dylan Brewer, why don't you go ahead and just introduce yourself to everybody? What do you got going on? What's your life about?
Right. So I'm an assistant professor at Georgia Tech. I got my PhD in economics from Michigan State. So I am a native Michigander, so I'm happy to be on the show.
Whoop, whoop.
Most of my research is in energy and environmental economics. And sort of originally, I was studying mostly household energy consumption. And I have, I think, the most papers on the economics of thermostat settings of any economist. So that's a very small niche I've carved out for myself. But I have recently been opening up a new research area, and that is studying the effects of air pollution on things like health outcomes and cognition and student performance.
Yeah, that's really cool. Because, I know when we first were talking about this, like, well, why are we going to have an economist person kind of in here talking about stuff? But that's kind of what you're studying. That's your niche, essentially.
Yeah, a lot of people think that economists are only studying things like the stock market and the economy, but it's not true. Economics is really a study of human behavior. And when human behavior interacts with things that affect health, that's where economists tend to get involved and can do really well.
Yeah. For sure. Super cool. So yeah, it'll be interesting to get your kind of take on these different things too from an economist's perspective. Awesome. Okay. So I wanted kind of to start this episode with really just talking about what is pollution? What actually is it? How is it harmful to us? Just so we can have an idea before we go into some of these studies that we're doing. And so, Mike, if you had to describe pollution, how would you describe it?
That's a great question. I guess I would, I think of pollution more than just kind of like air pollution, water pollution. I mean, there's all sorts of pollution, noise pollution, light pollution. So it's any, thing in the environment that is detrimental, to that ecosystem.
Yeah, for sure. And I like that you brought up things like noise pollution and light pollution, because we don't really think about that all that often. But yeah, that stuff definitely does go into pollution as well. And so, yeah, the definition is something that's introduced into an environment that's harmful to the organisms living in it. So,
wow, without even looking, I was pretty spot on. Just call me Merriam.
Webster. I got it. I got that.
You got that one.
It took me a second. That was clever, Chuck. That was good. So yeah, that's what pollution is. And then what we're mainly going to talk about is air pollution, which is pollution in the air. Surprise. And so why is this so important? Why is this a topic that is worth studying, worth us talking about it? And so human created air pollution, the statistic I found from the U.S. government is that it accounts for around 9 million deaths per year worldwide. And so fortunately for us, most of that is not in the United States, but this is worldwide. But yeah, as you can see, air pollution does cause a lot of negative effects in the world. And so that's why it's important for us to look into it. How can we prevent the negative repercussions and all that kind of stuff?
And the crazy thing is, Ben, and I'm sure you're going to talk about this, is air pollution and stuff like that does not mean necessarily it's generated in your neighborhood. Because I live, in a city which doesn't have a lot of industry and a lot of, creation of air pollution.
Yeah, like factories or that kind of stuff.
But it's consistently ranked as an area with relatively bad air quality, and it's because Chicago is a couple hundred miles away, and the prevailing winds bring all their junk to us. And so I know that even in pristine places like Alaska and the poles, the airflow, the air currents in the atmosphere take pollution and spread it worldwide. So what's happening in remote areas will affect, places close to your heart.
Yeah, for sure. And I know, Dylan, we've talked a little bit about this. I don't know if you have any comments on that about how wind flow and all that kind of stuff can change where the pollution goes and how you study things.
Yeah, actually, it turns out that using wind direction is one of the ways that you can identify a natural experiment. So, like Mike mentioned, wind can carry air pollution hundreds of miles. And I think we were all really aware of this this last summer when the wildfires in Canada combined with wind to make air quality in the United States for that short period actually the worst in the world.
Yeah. Yeah. And that actually was something. So I lived in Idaho for a couple years, and there would be forest fires in California. And then, wind would bring that down into Boise. It's kind of down in the bottom parts of the mountain. So in a valley. And then, all the smog would just kind of hang out around there. So it wasn't really anything happening in Idaho, but yeah.
Yeah. And it's crazy because I remember decades ago, you two were just twinkles in somebody's eye when Mount St. Helens erupted in Washington. And we had some of the particulate matter from that eruption carry all the way to Michigan.
Oh, really?
Yeah.
Wow.
So, those types of, natural disasters and stuff, again, that occur thousands of miles away can affect, your quality of air and what you're breathing. And that to me is just, incredible.
Yeah. Yeah. And you
go
ahead.
Mike mentioned a vocabulary word, particulate matter,
Yes.
which is actually one of the 6 criteria air pollutants that are regulated by the EPA through the National Ambient Air Quality Standards.
What's the EPA? Is that one of Ben's abbreviations again?
No, this is a real one, Mike. It's the Environmental Protection Agency, but good looking at. But yeah, so I'm actually glad you guys both brought that up, because that was the next thing I wanted to just touch on. Is what actually is air pollution? And so, Dylan, just like you said, there are kind of 6 major air pollution pollutants that the EPA identifies. I'm not going to go through all of them in detail, but the first one I did want to go into a little bit of detail with was particulate matter, which is what you mentioned, Mike. And so particulate matter is essentially just very tiny particles. And so these particles are less than 10 micrometers in diameter. So these are like microscopic. We can't really see these little particles in the air. But we can breathe them in, right? So our body, we want to breathe in oxygen into our lungs so that we can survive. And so if you have these super tiny particles, you're going to breathe those in as well. And then those can potentially get lodged into your lung tissue. So these little tiny particles are in our lung tissue, and these little tiny particles are actually toxic to the cells that are in our lungs. And so they're going to just sit in there. They're going to cause damage to our lung cells. And over a long period of time, that can cause a lot of serious problems. So it can cause chronic obstructive pulmonary disease or COPD. It can cause different kinds of lung cancers. And then it can also enter into our blood too, right? Our blood goes into our lungs to get the oxygen. And so it can also pick up these particulate matter pieces. And then that goes into the rest of our body and damages the rest of our body and cause cancer elsewhere.
The really scary thing is that particulate matter is small enough that it can cross the blood-brain barrier and can accumulate in the brain. So there are some studies that are linking things like dementia to the accumulation of particulate matter in the brain.
Oh, wow. That's wild.
So the stuff you breathe goes to your brain. Man.
Well, yeah, I mean, oxygen definitely does, but these other things can too.
Well, and I never thought about that because, yes, I know that, we breathe in particulate matter and stuff like that, but I always, thought more it just affected the pulmonary system and the lungs and didn't really think as much, which is just stupid on my part because I know that the lungs have a lot of blood vessels and stuff like that, and it's a great place to absorb things, but never even thought about some of those things getting into your body and going other places.
Yeah, for sure.
Great. Now I'm just going to hold my breath for the rest of my life.
Maybe wait until the episode's over, Mike, but then you can do whatever you want. So yeah, we have the particulate matter, and really these other ones I'm going to bring up act in a similar way. So, they get into our lungs and they cause damage throughout our body, but I'm not going to go into as much detail with them. So we have ground level ozone. And so you all probably remember talking about ozone and like the hole in the ozone layer and how that was a bad thing. And so ozone is a very good thing when it's up in the atmosphere. Like we want it there. It prevents harmful UV rays from damaging us. But if there's ozone down where we are and you're breathing it in, that can be toxic. And so we don't really want ground level ozone. Other things are carbon monoxide, sulfur oxide, nitrogen oxide, and lead. So those are kind of the 6 big things that the EPA is tracking in terms of air pollutants. And they all work in a kind of similar manner with small differences. Okay.
And to be clear, lots of other air pollution is bad for you. These are just kind of like the 6 major ones.
Yeah. The ones that are being tracked most rigorously, would you say, Dylan?
Yep.
Okay, cool. All right. So now we know that this is potentially an issue. We know what these things actually are. Now, what are the actual negative effects of air pollution? So there are 2 main kind of categories that I think about when it comes to the negative effects of air pollution. So first, which we aren't going to talk as much about, is climate change. And so having all of these different things in the air, in the environment, will cause changes to the climate, essentially, right? Because we have different things in the air. So there's different amounts of sunlight that are being reflected, et cetera. And so that'll cause things like less stable food production. Like imagine you run a farm and it's suddenly however many degrees colder than it normally is. You're probably not going to be able to make as much food as you normally do. That also causes things like our icebergs to melt. And so water levels increase. So beaches are now underwater. So there's less kind of like habitable land. You can potentially have animal extinction. Again, if you have changes in what kind of fauna or what kind of flora, so, your plants and your animals that live in an area.
I think I dated a girl named Fauna once.
I do not recommend dating fauna.
No. And you knew her.
I might have. And then also you can just have damage to your plant life. So that's kind of the climate side of things. But what about the kind of human damage side of things? In that case, there's, again, a couple of categories. First, we have short-term exposure. So if you just breathe in particulate matter, you breathe in nitrogen oxides, whatever, that's probably going to be pretty irritating. Like your ears, your nose, your throat are probably going to get kind of all scratchy and painful because your body doesn't like these toxic substances. It can also make it difficult to breathe. It can cause inflammation in your lungs, so you can't exchange oxygen very well in the short term. And if you have something like asthma or COPD, which we talked about, that can cause that to be exacerbated. And so you can have, again, more difficulty breathing in the short term as your lungs are just acutely damaged. So not great. I think we can all agree on that. The longer term side effects of breathing in a lot of stuff are just these long term kind of complications in our lung for the most part. So we already talked about chronic obstructive pulmonary disease. It can cause lifelong asthma in people if you have just, months to years of breathing this in. It can cause heart disease as these different toxic things get deposited in our heart. And people can potentially die from that. You can die from these lung diseases and heart diseases. I'm not trying to scare everybody. You're probably not going to die, but
too late. I'm already frightened.
Well,
So we've already established that I might have to breathe.
You might, maybe.
Okay. So what about masks? I mean, you see all these, people running around in masks when, the forest fires and stuff like that. Are we going to talk about masks and if they're any good for any of these particulates, or are they too small?
Yeah, no, that's a really good question. I don't know. Do you have any initial comments about masks, Dylan? I have a little bit of information on that.
I'm not super well steeped in the literature, but I do think that masks can reduce exposure to things like particulate matter and ozone.
Yeah.
But yeah.
Yeah, so you're pretty much spot on. So there are a lot of different masks out there, I'm sure, as we all learned during the COVID-19 pandemic. And it ultimately comes down to making sure you have the right kind of mask. And so just your kind of normal basic cloth mask probably isn't actually going to be helpful because these particles are just so small. They just go right through that fabric. But if you have something like an N95 mask, that can block out some of the particulate matter and issues that are going on with that. So
okay, yeah. And then those different things that you had mentioned that the EPA tracks. So a mask might be good for something like the particulate matter, like Dylan mentioned, but probably not going to keep out things like carbon monoxide, lead, and stuff like that, because those are gaseous at that point in time. And so,
they're even smaller than that particulate matter that we talked about, so they can go right through it.
So masks are not the be all end all. So we just can't totally screw over the planet and just expect a mask to save us.
Yeah, good point. And that's why hopefully we're going to talk about research and how we can track this stuff, because you're right. We can't solve the problem by just wearing masks. We got to do something about it.
All right.
Yeah. Awesome question, Mike. Okay. And so really the last thing I want to talk about in terms of damage is that breathing in air pollution is particularly damaging to pregnant women. So the fetus that they are carrying with them. As you can imagine, again, you're breathing in these toxic substances. The mother is providing everything for the child, right? And so if there's toxic substances in their blood, that can go to the fetus as well. So just something I wanted to highlight, that is another concern that we have. Okay, cool. And so why don't we actually take a second now here to pause for the Healthy Minute?
Today's Healthy Minute is Know Your Blood Pressure. High blood pressure can happen at any age and is known as the silent killer. High blood pressure can lead to problems with organs such as the heart, kidneys, brain, and eyes. You can monitor your blood pressure at most pharmacies, or you can purchase a meter to use at home. A normal blood pressure is 120/80. If you routinely have pressures above 130/90, you should follow up with your physician. If you have a blood pressure above 180/120 and have chest pain or shortness of breath, signs of a stroke or headache, you should call 911 or go to the closest emergency department. That was the Healthy Minute, brought to you by the Winery at Young Farms in Mecosta, Michigan. Please visit www.thewineryatyoungfarms.com for more information. Now, back to the Health Deli.
Boom, chicka boom, healthy, 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 healthy.
Welcome back, everybody. That was a fantastic Healthy Minute. And now let's get into a little bit more into how do you actually study this stuff? So we talked a lot about there are some damaging particles out there. There's some damaging gas. We talked about why it's damaging, what it does. But how do you actually study this stuff? How do we know that this is true? And so in past episodes of the Health Deli, we've talked about study design a little bit. So we talked about randomized control trials where we essentially had two groups of people, and then we controlled everything about them other than one thing. So in this case, let's say air pollution. So we said one people, you have to breathe in air pollution for 5 years. Another group of people, you're not allowed to breathe in air pollution for 5 years.
Can I be the second group?
Nope, Mike, you gotta be the first group, actually. Sorry. So that would be an example of a randomized control trial, but we don't really do that very much in this kind of research. Dylan, do you want to kind of explain to us why that's so problematic?
Because you're having people breathe in air pollution, which we think is going to kill them. So if you go and you ask the institutional review board whether you're allowed to, randomly assign air pollution to one group of people, they are going to tell you no, and probably are going to call your boss.
So is that not ethical or something? Like, what's the issue? I don't get it.
Yep, that's exactly right.
And that again is why Ben has a hard time doing clinical trials.
I'm learning a lot though through things like this. So yeah, we can't really just say like, we know this is dangerous, we're going to make people do that, right? Like that's just not okay to do. So we kind of have to get a little bit creative with stuff, right?
That's right. Yeah. So like randomized trials are so nice because you can get an unbiased estimate of the effects of something like a drug that you're going to give to one group of people and not another group of people, because you can make sure that the treatment group and the control group are comparable. But when we can't do that, we might be tempted to look at things like correlation. So if we were to measure the air quality in two different cities, we could compare the health outcomes in those two cities and look at these correlations to try to give us a sense of how bad air quality is for you.
Yeah, and this isn't something that's unique to environmental studies either. So we talked about, the ethics of this. When we're doing studies with drugs, we don't necessarily know that the drug is better than a placebo or a sugar pill, i.e. nothing. And so that's why we can do this kind of study, because like maybe it'll be beneficial, maybe it won't be. That's what we're studying it for. And there are safeguards in place. So let's say that we do a 5-year study, and by year 2, it's very obvious that the drug is better than a placebo. In that case, we would stop the study early. We would say, okay, it's no longer ethical to just give people nothing because we know that this drug is so much better than nothing. And so we just don't really talk about that as much because it's not as common, but it sounds like a very real issue in environmental kinds of studies. So you guys run into it a lot more frequently.
Yeah, that's right. Okay. And so now you're tempted to look at these correlations between different areas. One area that has good air, nice air quality, and an area that has bad air quality. But that's actually potentially going to cause a lot of problems because of things that we call confounders or selection effects.
Yeah, because we're not controlling for those other things, right? With a randomized control trial, hopefully all those things are the same. But in this case, there could be differences between our group, right?
That's right. So in a city like Gary, Indiana, that does have a lot of industry, the air quality is not good there. And if you compare that to a city like Grand Rapids, where you mentioned that there's less industry, there are different types of people that live in those two cities. Gary, Indiana is not a very wealthy city. And so you actually might see negative health outcomes in Gary relative to Grand Rapids. And you would be tempted to attribute that to air pollution, but really it's the effect of being low income, which can also affect your health.
And so, Dylan, those are things in the public health world we refer to as the social determinants of health. That means things other than a treatment or something very specific that can affect health, like access to health, income, education, and stuff like that. So what you're saying is it's tough to control those when you're dealing with cities with such different demographics, access, and infrastructure.
Yeah, and anytime that you're looking at things, at treatments or exposures that are not randomly assigned, such as is done in a randomized control trial, you're going to have variation that is correlated with variation in these other factors that is correlated with the exposure that you're studying. And that's going to cause the issues.
And another thing that I'm thinking of as well is, you talked about, the different cities and the different makeup of individuals. And then you can also run into problems with the genetics of the population. Scandinavian people have a different genetic makeup, and so they respond differently to different things as opposed to African Americans or, and that's been what, Pacific Islanders or Asians, and that's been really well documented. So, wow. In my world, I can just put 2 test tubes in 2 different rooms, and it's really easy to control for things. This sounds like a pain in the butt.
Yeah, it is. And there are a whole ton of different things that could possibly go wrong when you're just looking at these correlations.
Mm-hmm.
For example, emissions of pollutants is not necessarily random. So for historical reasons, power plants were sited near disadvantaged communities and low income communities. Highways were actually put through minority neighborhoods. And so people who are different races and different income levels are getting different exposures to pollutants non-randomly. The other thing we talked about is this mitigating behavior or defensive behavior. People wearing masks, people buying air filters for their homes. So some people might decide to take defensive actions to avoid exposure, and we might expect those people to be more highly educated. They're doing reading about air pollution. They're concerned. They're listening to the health deli. So they go out and they buy an air quality filter. And those types of people are going to be different than people who are not thinking about it. Another issue is non-random sorting behavior. So pollution sources reduce the prices of homes. So housing values reflect how clean an area is. And so if you get a factory in an area, that might actually reduce the home prices of nearby houses, and that's going to cause potentially low income groups to move into that area near the source of the pollution. And so again, you have this confounding effect of low income that you might be attributing to the air quality, giving you a biased estimate.
An interesting thing is I just remember hearing something along those lines in the Detroit area. People downriver in Detroit, some of those suburbs, there had been power plants and other factories that were in those areas that people were lobbying against because they were, linked to, truly decreasing home values, decreasing health and stuff like that. So, no, that's really interesting that, I guess people with less resources tend to get taken advantage of from those things, maybe because look, we're having jobs come here or, something else and see it initially as a benefit, or they can't afford to live anywhere except next to the smokestack.
Yeah, for sure. And so this all, at least when I'm hearing this sounds like impossible to design studies around, because we've talked about this again in the past with the deli. You have all these different things that I can't control for. How do I know that both of my groups have the same amount of people in that lower kind of socioeconomic
First
status?
off, the deli is not generating any air pollution. I'm going to just throw that out here. We are an entirely clean operation. Maybe there's a little bit of mesquite smoke coming from the smoker in the back, but I like to think that's not contributing significantly.
It's because we breathe it in because it's so delicious, right?
Yeah,
so it's fine. But yeah, so it sounds like it's incredibly difficult to design a study around all this stuff because there's just so many different confounding variables. Socioeconomic status, do you have an air filter or not? Do you wear masks normally? And we just don't know that information when we do these studies. So how do we solve this problem, Dylan? How can we actually look at this?
Yeah, that's where economists have actually gotten involved. And briefly, Mike, I hate to break it to you, but cooking fires, especially wood fires, if you were burning mesquite wood for your smoker, that's going to be some of the dirtiest emissions.
This is me sticking my fingers into my ear and saying, "Ma, ma, 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 I don't hear you."
But so getting back to how can we study this, the idea is to identify what we call a natural experiment. So you're trying to find something about nature that creates as good as random assignment of pollution to people. So in the lab, you have a treatment group and a control group.
Mhm.
And so in the field, you're trying to look for a natural treatment group that gets exposed to air pollution that looks similar to a control group that maybe randomly or accidentally does not get exposed. So let me give you some examples. There's a paper by Hollingsworth and Rudick from 2019 where they studied the effect of NASCAR and ARCA races switching from leaded fuel to unleaded fuel in 2007. And so they studied people who live really near NASCAR racetracks and compare them to people who live a little bit further away, who were not as exposed to the lead in the air from the races, and they find that when they switched from leaded to unleaded gasoline, that health outcomes improved for those people near racetracks.
Seriously? Wow.
Yeah.
And
And it's
so-
actually wild because apparently a single 3-hour race emits as much lead as the average airport does in an entire year.
No
Oh,
way.
really?
Holy.
Yeah.
Wow.
Yeah, that's wild. So that's interesting. So in that study, they essentially had the two groups of near the racetrack versus not near the racetrack. So they could look at the change in just the near the racetrack group and compare it to the other group, I'm guessing. That was kind of the idea.
That's right. And then you have to be really careful to make sure that you're comparing similar groups. So you
Mhm.
have to sort of look at their demographics, make sure that they're comparable, and so on.
Okay.
A similar type of research design was used by Curry and Walker in 2011. They looked at the Easy Pass stations that were installed at toll booths on highways.
Oh, okay.
So it turns out that if you have to stop all the way to feed money into a toll machine
Mhm.
and then accelerate all the way up to speed, that results in a lot more particulate matter from the braking and acceleration.
Oh, of the
than
tires
if
and the brakes.
then if you can sort of keep going a relatively fast speed as you move through the Easy Pass.
Oh, so it's more than just convenience. I mean, there's a health benefit. That's wild. I thought the Easy Pass was just there because people hated to slow down and whatever else. But wow.
Yeah.
Well, I don't even think that this is the main point of the Easy Pass installation, but that's what makes it a good natural experiment, because it's a complete accident that air quality near where they installed these Easy Passes improved. So you can think of that as almost a random assignment of improved air pollution to people who live near the highway when a toll booth switches from or gets its Easy Pass technology.
And interesting because I've heard similar things like hybrid cars, and that's one of the big things, one of the biggest wastes of gas and emissions is, when a car stops in the city at a stoplight or a stop sign, you're not going anywhere, but you're burning fuel, and that's all coming up. So that, it's almost kind of, take advantage of those times to reduce fuel consumption and emission. And it can really impact, it sounds like, quality of life for the people that live in those areas.
Yeah, for sure. And now I feel bad that I never got an Easy Pass all the years that I lived in Ohio. So
yeah, but you
that
made up
guilt's
for it
here
when
now.
your car was broken and you had to ride a bike to work all the time.
That's true. I did. I made up for it. Okay, cool. So Dylan, could you just give us also an example of like the wind direction thing that we talked about? Because that also sounded super interesting. And how we can use that for our studies.
Yeah, so this is actually a relatively new research design, and from my perspective, this is the most promising research design for studying the effects of air pollution on health and cognition.
Mm-hmm.
So what people have been doing is they have been looking at the random variation in wind direction and how it brings pollutants to an area and looking at how those short-term differences in exposure that are being assigned randomly because of changes in the wind affect health outcomes. So just like Mike mentioned, your local air pollution is going to be affected by emission sources that are very far away. And so if you live in Grand Rapids, when the wind is blowing from the south to the north, so I guess from the southwest to the northeast, it's going to carry air pollution from Chicago. When the wind blows in other directions, it's actually going to carry relatively clean air, most likely. So we can look at different cities on different days and whether they are upwind or downwind from distant pollution sources, and that creates random assignment of a dose of pollution exposure across cities. Or you can think about it this way: some people become the control group, they get clean air, and some people become the treatment group, they get dirty air, just because of the wind exposure. And that will allow us to go beyond correlation and make a causal claim that if we see an increase in things like mortality or hospitalizations, that there's a relationship between air pollution.
Now, when you say causal, what does that mean?
Yeah, so causal means so in economics, causal means that we can interpret it as having an effect that can be attributed solely to that particular cause. So when we talked about just looking at correlations of air quality in different areas over time with health outcomes, that is just a correlation because we have all these potential confounders like income variation that's going to be correlated with the exposure to air quality. But when we have a causal estimate, that means that we have eliminated all these potential confounding effects, and we have the all else equal effect of pollution on health outcomes.
So essentially, we're trying to say that with this hopefully better kind of data, we can more reliably say that this change we saw was due to the air pollution, is kind of what you're saying.
Right. And we both want to know whether there is an effect, and we want to know how large the effect is, because we need to know how damaging air pollution is and compare that to how costly it is to reduce air pollution, to sort of tell us whether it is worth controlling that air pollution.
Gotcha. Okay, cool. So that is, incredibly interesting. I'm glad that we're having these more nuanced ways of looking at the studies. I wish we could talk more about it, but we are actually very close to time here. So Dylan, I want to give you one last floor. Do you have any kind of last minute things you want to tell maybe aspiring researchers about how to try and find these naturalistic kinds of experiments?
Yeah. So, I mean, the key to identifying a good natural experiment is to find stuff that is going on sort of in nature or in the field that causes as good as random variation. So some really good candidates for that are unexpected weather changes for air pollution, accidental reductions in pollution due to different policies. So the closure of power plants, or the Easy Pass example. I have a student who's looking at the collapse of a bridge in Minneapolis that shut down a highway for an entire year, improving air quality for schools that were near that highway.
Okay.
So thinking about these sort of accidents or things that are kind of like randomly affecting how people are exposed is the key. And then you need to think really hard about how humans are going to behave in order to thwart the randomness of that pollution assignment. And that's kind of why economists have gotten involved in studying these environmental effects, because we think about how humans are trying to sort of like optimize and improve their own outcomes. And that has helped us to identify potential mechanisms that could sort of thwart what we think of as a natural experiment.
So before we sign off, you mentioned random things. What about the pandemic? I had heard and saw, that was some remarkable effects on pollution, especially in some bigger cities when nobody drove. Mm-hmm. Have you looked at the upside of the pandemic?
Yeah, so actually, I actually have a paper on this. I studied the effect of the pandemic on electricity consumption, and it turned out that during the early lockdowns, there was a reduction in electricity consumption, but during the summer of 2020, there was actually more electricity consumption as people started working from home while lights were kept on in empty offices, and so you were kind of like cooling using air conditioning in two different locations. So as far as electricity consumption goes, it was kind of a wash. But there are other studies that look at how traffic volumes changed during the pandemic, and so that actually creates some random variation if you were on a previously busy street and the pandemic causes there to be fewer cars, and you're comparing health outcomes of people who live on the busy street versus people who lived on a not busy street where the pandemic didn't really affect the number of vehicles that were traveling on any given day, then now you suddenly have a treatment group and a control group that are getting different exposures to air pollution. And what's cool about that is that you can also disentangle the effect of the pandemic from the effect of the air pollution if you have this treatment group and control group that are both also experiencing the pandemic, if that makes sense.
Wow. Very cool.
Yeah, super interesting. Awesome. Well, thank you, Dylan, Dr. Dylan Brewer, if I do say so, for joining us on this episode of the pod. One last thing. I think you told me recently that you just published a article that's really about all of this stuff. Do you want to just point the people to where they could find that if they want to read up more?
That's right. So I just published an article reviewing causal inference approaches to studying air pollution, and that is in the annual reviews of Resource Economics Journal. Mm-hmm. And I'm also working on some work adding air quality monitors to South Atlanta at schools, and so we're excited to learn about how air pollution affects cognition in those schools.
Fantastic. Very cool. Awesome. Well, thank you, everybody, for joining us today. Thank you, Dylan, for sharing us your expertise.
I'll go turn off the darn smoker.
I appreciate it, Mike. And with that, thank you, everyone, for listening to the Health Deli, and we'll catch you in the next one.
Thanks for stopping by the Health Deli to sample some of our wares. We're open 24/7 on Facebook and Twitter at The Health Deli, or visit thehealthdeli.com to send us a question or find any of our locations. Please come again. We will be regularly stocking the shelves with fresh content and new wellness specials. As always, we want to give a special thank you to Andrew Tingley and the crew at Ferris State University's Television and Digital Media Production Program. Until next time, so long from the Health Deli, where the topics are tasty, the takes are fresh, and the discussion is free.
All right.
Yeah, thanks for having me on. That was fun.
A lot of heavy stuff in there.
Yeah.
I didn't even get to talk about how I am a random variable.
You're a confounder.
Yeah, I am definitely confounding every time I open my mouth. It's just random.
That's okay. You could be an error term like Ben.
Ooh. Wow.
Yeah, I appreciate it. And take care, guys.
See you, Dylan. Have a good one.
Yeah, I love the fact now that finally Andrew's got a microphone and he can participate like a human.
I'm here, guys.
I was locked in the cooler for the past...
Why didn't you let me out? You saw me.